Picture a mannequin. Now picture a lifelike CGI human with almost perfect skin, except the eyes are just slightly wrong. If the second one made your skin crawl more than the first, your brain just proved something. A very old threat detection system just fired, exactly as designed. This wasn't discovered in a lab. It was sketched on paper by accident. In 1970, Japanese roboticist Masahiro Mori was trying to describe something he'd noticed while working on human-like machines. He drew a simple graph. One axis, how human something looks. The other, how comfortable people feel looking at it. The line did something nobody expected. As robots became more human-like, comfort rose steadily, just like you'd assume. A cartoonish robot felt friendly. A more detailed one felt even more endearing. Then somewhere around 60 to 95% human likeness, the line stopped climbing. It collapsed sharply into deep, specific discomfort. It only climbed back out once something became genuinely, convincingly human. Mori called that collapse the Uncanny Valley. And for over 30 years afterward, nobody could fully explain why it existed at all. The dip isn't gradual either. That's what makes it strange. One more step toward realism, right in that zone, doesn't help. It makes things measurably worse. A creature at 50% human likeness can feel perfectly charming. The same creature pushed to 85% can suddenly feel disturbing, even though it's objectively closer to looking like you. You felt this yourself, whether you knew the name for it or not. A 2004 animated film used photorealistic human characters and unsettled audiences worldwide, despite genuinely impressive technical work. Viewers couldn't explain it. The characters looked almost right, something behind the eyes still read as dead. For decades, this stayed a design instinct. Animators felt it. Nobody could prove it. Researcher Carl McDorman set out to change that, running study after study, testing human comfort across the entire realism spectrum. The valley kept showing up, every time, not a vague cultural feeling people had talked themselves into, a real, repeatable, measurable dip, so the shape was confirmed. The why was still missing entirely. Eye-tracking studies got closer. Researchers found people can rarely explain what feels wrong on an uncanny face, but their eyes tell a different story. Gaze locks onto the eyes and mouth first, every time. A blink held a fraction too long. A smile that never quite reaches the muscles around the eyes. You're not looking at the whole face. You're auditing two specific spots, without even deciding to. Then, in 2012, psychologists Kurt Gray and Daniel Wegner published something that reframed the entire problem. Their study in the journal Cognition barely mentioned appearance at all. It was about something else, mind perception. Here's the theory. Your brain constantly, automatically, judges two separate things about anything it sees. Does this have a body? Does this have a mind? Two questions answered in a fraction of a second without you ever noticing the process running. Most things sort instantly. A rock, neither. A person, both. A boxy metal robot, body, no mind, filed away without confusion. But a near-perfect android breaks the sorting system completely. The body says human. Something about the eyes says empty. Two conflicting answers, both arriving at once with nowhere clean to file them. That conflict is the actual trigger, not the face itself. Gray and Wegner tested this directly, showing participants a range of images, some clearly machines, some clearly people, some caught in between, and asked them to rate two separate things: how physically capable each one seemed, and how much of an inner mental life it seemed to have. The results lined up with the theory. It was never the presence or absence of either quality alone that predicted discomfort. It was the specific mismatch between a fully human-looking body and a mind that seemed to be missing. It was never about the face. It was about the mismatch. There's a second theory. It doesn't replace the first one. It runs right alongside it, aimed at something older and more physical: disease. Your ancestors needed to spot illness fast. Sickness spread through contact. A corpse meant danger nearby. Skin that's subtly wrong. Eyes that move a fraction off. A face that's almost, but not quite, symmetrical. That could be enough to trip an alarm built millions of years before robots existed. This isn't a metaphor for how the alarm works. Researchers studying disgust and disease avoidance behavior have found that people show heightened skin conductance responses, a genuine physiological stress marker, when viewing images with subtle asymmetries or skin irregularities, even when consciously told the image poses no threat at all. The body reacts before the mind gets a vote. Under this theory, an almost perfect human face doesn't register as robot at all. Somewhere underneath conscious thought, it registers as something closer to a corpse that's still moving, not comfortable, apparently very old. If it's really that old, it shouldn't need culture to teach it. So researchers tested babies. Infants too young to have seen a single robot, horror movie, or wax figure. The results held. 12-month-olds showed measurably more distress toward human-like figures with subtly wrong features than toward faces that were either clearly cartoonish or clearly real. Researchers tracked this using preferential looking time, essentially measuring how long an infant chooses to keep watching something versus turning away, one of the few reliable tools available for reading the reactions of a child who can't yet talk. A baby who has never once encountered the concept of uncanny still avoided the exact same zone adults do, and here's where it stops being a human story entirely. In 2009, researchers Sean Steckenfinger and Asif Ghazanfar ran an experiment on macaque monkeys, published in the Proceedings of the National Academy of Sciences. 3 types of monkey faces: cartoonish, photorealistic, and stuck in between. They tracked exactly where the monkeys chose to look. The monkeys avoided the in-between faces. The same zone, the same pattern. A species that never built a robot, watched a movie, or touched a screen still flinched at precisely the spot your brain flinches at. Whatever this mechanism is, it was running before humans and monkeys even split from a shared ancestor. This isn't just a curiosity anymore. It's a design constraint, and entire industries build around it on purpose. Animation studios learned to dodge the valley deliberately: larger eyes, softened proportions, simplified skin, anything to stay clear of the danger zone instead of stumbling into it. A near miss at photorealism reads as more disturbing than an honest cartoon ever will. This is part of why so many modern animated humans still look slightly stylized, even when the technology to render them with total realism already exists. Studios aren't limited by what's possible. They're avoiding a specific, well-mapped stretch of the human likeness spectrum on purpose. Robots take the opposite route to the same safety: visible joints, simplified faces, plastic that looks like plastic, not because the technology can't go further. Because a robot that looks 70% human unsettles people more than one that looks 30% human, or 99%. Engineers building humanoid robots have openly discussed this exact trade-off, choosing to keep a machine's mechanical nature visible rather than chase a level of realism that would land it directly inside the valley instead of past it. The extremes are safe. The middle is where things go wrong. And now there's a new frontier for the exact same glitch: AI-generated faces and voices, hands with one too many fingers, backgrounds that don't quite obey physics. A voice that's 90% natural, which somehow unsettles people more than a voice that sounds obviously robotic, because the last 10% of wrongness stands out harder the closer everything else gets to real. This might be the clearest modern proof that the mechanism was never really about robots at all. It was about the gap: push something close enough to real, and any remaining flaw doesn't blend in. It gets highlighted, magnified by contrast against everything around it that looks correct. Same ancient system, new material, pixels and waveforms instead of skin. So the next time something almost human sends a shiver through you, a doll, a robot, a face on a screen that's just slightly off, know exactly what's happening. You're not overreacting. You're not imagining it. You're running a detection system built for one urgent question, answered faster than thought: is this alive, or is this wearing the shape of alive? Your ancestors needed that answer instantly, every single time. You still get it instantly too. You just call it a shiver, and you never find out why, because the part of your brain running this never bothered to explain itself to you in the first place.